Imagine a world you can't recognize, a world buried under a blanket of ice so thick it reshapes continents. This wasn't some distant alien planet. This was our Earth, just 20,000 years ago, during a period we call the Last Glacial Maximum. Take a moment and picture it. North America, as we know it, is gone. A colossal ice sheet, in some places over 2 miles thick, covers everything from the Arctic down to modern-day New York City and Chicago. The sheer weight of this ice is immense, pressing down on the Earth's crust, literally depressing the land beneath it. Europe is similarly entombed. The British Isles are connected to the mainland, not by bridges or tunnels, but by a vast, frozen plain, and a single massive ice sheet stretches from Scandinavia across northern Germany and Poland. The world is a stark, breathtakingly different place. Sea levels are dramatically lower, almost 400 feet lower than they are today. Why? Because a huge amount of the planet's water is locked up in these gigantic glaciers. The familiar coastlines of our world are gone. A land bridge, known as Beringia, connects Asia to North America, creating a highway for early human and animal migrations. Australia, New Guinea, and Tasmania are fused into a single supercontinent called Sahul. The landscapes that aren't covered in ice are transformed. Vast, wind-swept plains, known as tundra and polar deserts, stretch out from the edges of the ice sheets. The air is colder, drier, and dustier. Fierce, relentless winds whip across these barren expanses, carrying fine glacial silt for thousands of miles. The lush Amazon rainforest? It's shrunk to a fraction of its current size, replaced by grasslands and savanna. It's easy to think of this as just a very, very cold winter, but that doesn't capture the scale of it. This isn't just about temperature, it's a complete reordering of the global climate system. We call this an ice age, but that term itself can be a bit misleading. An ice age isn't a single, continuous deep freeze. It's a long-term reduction in Earth's surface and atmospheric temperature, resulting in the presence or expansion of continental and polar ice sheets and alpine glaciers. Within a larger ice age, we see cycles of colder periods called glacials, like the one I just described, and warmer periods called interglacials, like the one we're living in right now. So technically, we are still in an ice age, the Quaternary glaciation, which began over 2.5 million years ago. We're just in one of the warmer, more pleasant chapters of the story. But back to that frozen world. Life, as you can imagine, was tough. It was a world ruled by giants. Woolly mammoths, with their long, curved tusks and shaggy coats, roamed the tundra in great herds, their heavy footsteps echoing across the frozen ground. Saber-toothed cats, like the formidable Smilodon, with fangs like daggers, hunted giant ground sloths and bison. Dire wolves, larger and more robust than modern gray wolves, stalked their prey across the icy plains. And among these titans, our ancestors, Homo sapiens, not only survived but thrived. They were masters of adaptation. They lived in small, mobile groups, following the herds of large game that were their lifeblood. They crafted sophisticated tools from stone, bone, and ivory. They clothed themselves in warm furs and hides, learned to control fire for warmth and cooking, and built shelters from mammoth bones and animal skins. They were artists, too. Deep within caves in places like France and Spain, they left behind a breathtaking legacy. They painted vivid, dynamic images of the animals that dominated their world. Galloping horses, charging bison, and majestic mammoths. These weren't just crude drawings. They were expressions of a deep connection to their environment, a way of understanding a world so profoundly different from our own. They tell a story of a people who were keenly observant, resourceful, and possessed a rich cultural and spiritual life. For tens of thousands of years, this glacial world was the norm. The ice was a permanent, seemingly invincible feature of the planet. It dictated the flow of rivers, the shape of mountains, and the boundaries of life itself. From the perspective of someone living at that time, it would have been unimaginable that this frozen kingdom could ever end. The ice was everything. It was the world. And yet, it did end. Something began to stir. An invisible force, a power of unimaginable scale, started to work against this global deep freeze. The climate system, locked in a glacial state for millennia, began to falter. This wasn't a slow, gentle thaw. The transition was volatile, marked by dramatic, rapid shifts in temperature and weather patterns. The world started to experience wild swings, like a system in chaos. What could possibly have the power to challenge a 2-mile thick sheet of ice covering entire continents? What force could warm the entire planet, melt trillions of tons of ice, and raise the sea level by hundreds of feet? The change didn't come from a single cataclysmic event, like a meteor strike. The answer was far more subtle, yet infinitely more powerful. It was a change in the very rhythm of the Earth itself. Scientists have pieced together this incredible story by studying ice cores from Greenland and Antarctica, deep-sea sediments, and ancient pollen records. They found that the Earth's climate is governed by long, predictable cycles. These are called Milankovitch cycles, named after the Serbian scientist Milutin Milankovitch, who first theorized them. These cycles are all about Earth's journey through space. They describe subtle, periodic changes in our planet's orbit around the Sun. There are three main components. First, the shape of Earth's orbit, its eccentricity, changes from nearly circular to more elliptical over a cycle of about 100,000 years. Second, the tilt of Earth's axis, its obliquity, shifts back and forth between about 22.1 and 24.5 degrees over a 41,000-year cycle. This tilt is what gives us our seasons. Finally, there's the wobble of the Earth's axis, like a spinning top, known as precession, which has a cycle of about 26,000 years. These cycles don't dramatically change the total amount of solar energy the Earth receives. Instead, they change where and when that sunlight hits the planet. Around 20,000 years ago, these orbital cycles aligned in just the right way. They began to increase the amount of summer sunlight falling on the northern hemisphere. It started small. Summers in the north became just a little bit warmer for a little bit longer. This meant that during the short summer months, a little more snow and ice melted than had fallen the previous winter. Year after year, century after century, the effect compounded. The brilliant white surface of the ice, which had reflected sunlight back into space and kept the planet cool, began to shrink. As the ice melted, it exposed the darker land and ocean beneath it. This darker surface absorbed more of the sun's energy instead of reflecting it. This created a powerful feedback loop. More absorbed heat meant more melting, which exposed more dark surfaces, which led to even more warming. The Great Thaw had begun, and it was unstoppable. At the same time, the warming oceans began to release vast amounts of dissolved carbon dioxide into the atmosphere. This CO2 acted as a greenhouse gas, trapping more heat and accelerating the warming even further. The climate wasn't just warming, it was entering a new state. The retreat of the great ice sheets was a messy, chaotic, and often violent process. As the glaciers melted, they released unimaginable quantities of fresh water into the oceans. Sometimes this happened catastrophically. Enormous lakes of meltwater dammed by ice would suddenly burst free, unleashing floods of biblical proportions that carved new landscapes in a matter of days. These megafloods scoured the earth, creating features like the channeled scablands in Washington state. The end of the Ice Age wasn't just a warming, it was the birth of the world we know today. As the ice retreated, forests began to advance, covering the barren tundra. Rivers charted new courses. The land, freed from the immense weight of the ice, began to slowly rebound, a process called isostatic rebound that is still happening today in places like Scandinavia and Canada. The animal kingdom was thrown into turmoil. The giants of the Ice Age, the mammoths, the saber-toothed cats, and the giant sloths, couldn't adapt quickly enough to the rapidly changing climate and the new vegetation. Their world was vanishing. Coupled with the pressures of increasingly sophisticated human hunters, they were driven to extinction. A whole world of megafauna disappeared forever. This incredible story of the Earth's past holds a profound lesson for us today. It shows us that our planet's climate is not static. It is a dynamic, powerful system capable of dramatic and rapid change. The same forces that ended the last ice age, orbital cycles, greenhouse gases, and feedback loops, are still at play. Today, we are witnessing another period of rapid climate change, But this time, the primary driver isn't a subtle shift in Earth's orbit. It's us. The immense amount of carbon dioxide we've released into the atmosphere in a very short time is pushing the climate system in a new direction. By studying the deep past, we can better understand the potential consequences of our actions and the incredible power of the planet we call home. The Earth has the power to create a world of ice, and it has the power to melt it away. And understanding that power is more important now than ever before. Thank you so much for joining me on this journey back in time. If you found this as fascinating as I do, please hit that like button and consider subscribing for more stories about our incredible planet. See you in the next one.